One wire steadying the Ross's wind turbine tower stretches from a point 40 feet high on the tower to a point on the ground 25 feet from the base of the tower. How long is the wire? We're shown an image of a house next to a turbine tower. The height of the turbine tower is labeled 40 feet, and the wire is 25 feet from the base of the tower. The first step is to let x equal the length of the wire. So I'll go ahead and label the length of the wire x in our picture. The triangle formed is a right triangle. Therefore, we can use the Pythagorean theorem. A squared plus b squared is equal to c squared, where c must be the hypotenuse, or the side across from the right angle. Substituting the values we know, then, a or b could be 25 feet, so we have 25 squared, plus an a or b could have been 40 feet. But I'll use b then, is 40, so 40 squared, is equal to c, the longest side, is x squared. So the equation we need to solve is 25 squared plus 40 squared is equal to x squared. Simplifying gives us 625 plus 1,600 is equal to x squared. Adding, we have 2,225 is equal to x squared. Taking the positive square root of both sides, because this is a distance, we have the square root of 2,225 is equal to x, which is approximately 47.170. Therefore, the length of the wire is approximately 41.170 feet.